This is your maths for week 8. We're going to be talking about time. So, just to very quickly go through the basics, you should already know how to read an analog clock. So, you know that the shorthand is the hour hand, you know that the long hand is the minute hand, and you know that the hour hand is going around clockwise as is the minute hand. Okay, so for instance, if we look at the first clock, you can see that the shorthand has gone around all the way from the 12 to between the 4 and the 5. Now, you might be thinking, I don't know which one it is, I don't know whether it's 4 or whether it's 5. It's in between 4 and 5. It's like 4.5. So therefore the hour would be 4 because it's just gone past 4. If we keep going and look at the minute hand, we can see that it's pointing towards the 9, and we need to learn that the 9 means 1/4 to. Now 1/4 means that there's 45 minutes past. That's the same thing. So it's 4:45. If we wanted to write 1/4 to, then we would need to do it to the next hour, because what it means is that effectively on the clock there are 4 quarters. You have 1/4 left to go until you get to the next hour, so therefore it'd be 4:45. Okay, you need to very carefully just check the hour hands and think about which hour it is, especially if it's 1/4 to. So remember that if it's got minutes past the hour in digital, then it will have the what it's just gone past. If it's talking about 1/4 to, we need to talk to what hour it's about to get to. This one's talking about digital time. You need to use a sharp pencil and a ruler. Draw the short and long hand really carefully. Try and make sure there is actually a difference. Okay, normally when people do clocks, they end up with two that look almost identical sizes, and then it looks really difficult to tell which one is the short and which one's the long hand. Also make sure that it's not just pointing at the number. For instance, if I pick 5:15, then we know that the hour is 5. But it's not dead on 5 o'clock, it's not 5 o'clock. It's 15 minutes past by then. So 1/4 of the next hour has already gone. So therefore the hand should be 1/4 of the way between 5 and 6, because 1/4 of it's already gone. Okay? Make sure that the hour hands are correct throughout. There are some tricky ones. The last one, the minute hand, is missing. Circle the time the clock is showing. You should be able to guess based on the position of the hour hand between the 2 and the 3 as to whereabouts in the hour it is. The next questions are about digital time. We already know how to use the digital clock using 12 hours, where you'd start at 0, 0, 0, go through 1 AM, 2 AM when it's really dark outside, 3 AM, 4 AM, 5 AM, 6 AM, 7 AM when you're having breakfast, 8, 9, 10, 11, 12 where it's lunchtime. Okay? If you're doing the 12-hour clock, you then start all over again, and you have effectively from 12 you start again at 0, 01, and then you keep going all the way again to 12. Okay, so effectively you've got from 0, where that's AM, 12 PM, this one's PM, and this one's again midnight. It's the same time, 0 and 0, 0, 0 and 12. This version are all the same. Okay, and that's the 12-hour clock. Now today we're talking about the 24-hour clock, which is normally easier because it means that you can tell whether it's morning or afternoon without the use of AM or PM. So, for instance, if you're going to eat your breakfast at 7:30 AM, what we do in 24-hour time is we do it using 4 numbers, so 07:30. And then we all know that that's the start of the day because it's got an O in it. If we want to say that you are eating dinner at 7:30 PM, then we add 12 onto the hour because we've already had 12 in a day and then we've had another 7. So therefore we have to add 12 on. So 12 add 7 is 19:30. And then we know that's PM without needing to write it. So you can see on the Let's Learn, you start from 12 midnight all the way past 12 noon and get to 12 midnight, and then you can see the link in the 24-hour clock. So you've still got 6 a.m. but 0600, then 12 noon is 12 o'clock, and then 6 p.m. is 1800, and then back to 00 at midnight. It should be clearer, so that's the reason why things like flights are always shown in 24-hour clock, is that no one accidentally turns up to the airport 12 hours early or 12 hours late. So, the train schedule between town A and town B. Now, the funny thing with this question is that the questions are in 24-hour clock, but the table is in 12-hour clock. So, what you would do is either change all the questions into 12-hour or change the table into 24. Personally, I changed the table because then you haven't missed anything. So, 5:30 p.m. I know that I've got 5:30, but it's p.m. so I need to add on 12 hours. So 12 add 15, 12 add 5 even is 17:30. So I know that's replacing that time. If you change all the others, the question should be much easier to answer. In 1954 Oxford, Roger Bannister became the first person to run a mile in less than 4 minutes. How many seconds are there in 4 minutes? So you can see that in 1 second, in 1 minute, you should know that there are 60 seconds. So what you're doing is multiplying by 60. And that sounds quite difficult. It's not all that difficult. If you've got 4 minutes, you could do column. 0 times 4 is 0. 6 times 4 is 24. Or you could use known facts. So you know that if I do 4 times 60, I know that 4 times 6 is 24. So 4 times 60 would be 240. Solving problems on duration of time. Okay, so time is special because it only runs between 0 and 60. If you think about it, there's 60 seconds in a minute, not 100 like everything else that we do in maths. Because in maths, if you want to change column and you want to go from the tens to the hundreds, then you're timesing by 10 because you're working on a basis of 10. Time doesn't work like that. It works on a basis of 60. So therefore, we have to be careful when we're doing duration not to use anything like column because we will get it wrong. So for instance, if you had 7 a.m. but you wanted to go from 7:45 and then you wanted to add 16 minutes, if you tried to do it in column, you would end up with a time that doesn't exist. 7:61 isn't a time, okay? Because 60 seconds in a minute, that would be the next hour. It would be 8:01. But it becomes more difficult, so it's really important to remember, don't use column. You will get yourself in a muddle. Okay, what we do is we add on individually in jumps until we get to the next hour. So 10:40, we know that the next hour is going to be 11 o'clock. At that point, if you wanted to add an hour, we know we would have 12 o'clock. And then we know we might have 1 p.m, 2 p.m, 3 p.m. We can count on amounts. So for instance, with this one, 10:40 add 20 minutes is the time taken to get to 11. We then need to add another 2 hours on and we can find the right time. If we need to add on something at the other end, at that point it's easier to realise that we need to change hour. Personally, I would always, for an answer like 10:40, get to the next hour and then work out where to go from there. It's much easier to add on, say, 40 minutes to 11 o'clock than it is to add 60 minutes onto 10:40. Okay, because it involves making sure that you change the hour and not forgotten that, and it's very complicated. So please just count on, don't use column, and try and get to the hour because then that will help you to work out the right answer. Okay, you should have done this in the last couple of weeks. So what fraction of each of the following blocks is shaded? write each fraction. So this one, you know that each column is worth 10 because it's a number square. So you've got 10, 20, 23. The whole amount you can count is out of 100. Now, if I was going to write that as a decimal, then I know that it will be 0.23 because this number is a tenths number and this number is a hundredths number. Okay, if I wanted to, I could prove it. So for instance, I can write 23 because all that really means is that I'm dividing it by 100. So I'm going to do what we do when we divide by 100. So that's going to be my tens. That's going to be my ones, tenths, hundredths. Okay, so I'm going to divide it by 100. I'm going to take it down 2 columns to the right. So let's move the 2. 1, 2 needs to go there. 3, 1, 2 needs to go by the hundredths. And I need to put a 0 point because that's my decimal point line in. Okay. If it's slightly more tricky than that, and you've got something like a half, before you can write it as a fraction, you need to get the bottom of it to be 100. So you should know that 2 times 50 is 100. Therefore, I should multiply the same amount on the top. So 1 times 50 is 50. So with this one, I'm just going to talk about place value. So 5,435, add 3,523. That one lines up easily because they're both thousands numbers. Some of these are not so easy. So if I take a look at 74.64, I'm going to put my decimal point line in so I definitely don't make a mistake. I'm taking away 2.17. 2.17. Okay, so use the decimal point line where you need to make sure you're lining it up, and just think really carefully about it because some of these are quite tricky. Okay, related facts. 3 times 5, you know, is 15. Effectively, what you've done with 3 times 50 is you have done 3 times 5 times 10 because 50 is 5 times 10. So therefore, if you're going to do this, and you would do 15 times 10, which is 150.